Okay. Good morning everyone. So the last class we talked about paired t-test, right? Remember, so now the question is, what is the advantage and disadvantage of doing a paired t-test? When do we do and what is, can I simply close my eyes and do paired t-test always? What is the problem with paired t-test? There are two issues at least. What are the issues? The way in which experiments have to be conducted itself is fixed in a paired t-test. What do I mean by that? Every sample has to go through test using the two different sensors or two different material, whatever, right, whatever we want to. So each sample has to be exposed to two types or whatever types you want to call it. The degrees of freedom is going to be significantly reduced if you do paired t-test compared to a unpaired t-test. Okay. So that is one big drawback. Okay. But when to do paired t-test then? When should I do paired t-test? So I have given you with n minus 1 degrees of compared. Okay, so the degrees of freedom is different, and when should I do a paired t-test then? So when there is, when conditions, underlying conditions affect the outcome of an experiment, then you have to actually do the experiments for the under the same conditions for both the kinds of equipments what you want to test, right. So it is, if the experiments, if the outcome of the experiments are dependent upon conditions, then it is required to perform experiments under homogeneous conditions, and when you want to perform homogeneous tests under homogeneous conditions, it is better to do a paired t-test. Okay, clear, right? If you want to maintain homogeneity, because if homogeneity is an important factor that influences your outcome, then it is important to think about paired test, because in paired t-test you are actually maintaining homogeneity naturally, because you are conducting the experiment on the sample using two different types of metal tips or equipments or whatever, right. So paired t-test is all about maintaining homogeneity, and if homogeneity is important and if it influences the output, then you have to do paired t-test. Clear? And it will come up with its own drawbacks. Okay. And in many paired t-tests there is a correlation that exists between x1 and x2. We will see what is correlation. Okay. So you will see that the variance of d bar, okay, what is d bar? X1 bar minus x2 bar minus whatever you want to call it, delta naught, right, that is the deviation, right. Variance of d bar is, there is a relationship as well, covariance as well in many a times. Okay. So although pairing will lead to a smaller, so what happens is the overall variance, so the overall variance, what happens is it increases or comes down? The variance reduces. That is actually a good thing or a bad thing? Good thing, right. Variance decreases. On one end your degrees of freedom reduces, but your variance also reduces, mostly because most of the time there is a relationship between your, so this is something which we derived, this is what variance of x plus y, we derived it in the last class, we derived it earlier also. Variance of x minus y is what? Variance of x plus variance of y minus 2 times, this is what I am going to call it as covariance. We will talk about this in detail today. Okay. So this is what I am going to call it as covariance. So now this is going to be, if the variances are equal, then I have 2 sigma squared into 1 minus rho by n. Okay, this is nothing but call it as rho. Okay. So we will talk about this later, this one, how did we get this, we will talk about this later, but the nutshell is the variance decreases. Okay. So pairing will often lead to a smaller value of the variance, but it has a loss of n minus 1 degrees of freedom. Okay. We know that increasing the degrees of freedom increases the power. Why? Increasing the degrees of freedom, what will happen? Alpha is fixed, beta is dependent upon n, which is degrees of freedom. So beta will increase, I mean 1 minus beta will increase, beta will decrease, 1 minus beta, which is power, will increase when degrees of freedom increases. Okay. So if you do a pair t test, the power of the test goes down. What is power of the test? The ability to reject null hypothesis if it is false, that is nothing but power of the test, which is 1 minus beta. Okay. 1 minus beta goes down or beta increases because your degrees of freedom gets affected, reduces. So if the experimental units are relatively homogeneous and the correlation within the pairwise pairs is small, the gain in precision attributable to pairing will offset by the loss of degrees of freedom. So an independent sample experiment should be used. When to use independent? When the experiment is itself, when the units are relatively homogeneous, that is performing heart rate on him and me are the same, which will not ever be, right. So in our case we cannot do a unpaired t test, but there are cases where, not in biomedical but many cases where the samples are relatively what, homogeneous in itself, and pairing does not add any value, pairing does not add much of value, there you can do independent test. Whereas if the experiment units of relatively heterogeneous, so the underlying population relative units are heterogeneous, that is the results will depend upon in what sample you are doing. Okay, that is the issue, the results will depend upon the sample itself, the particular sample itself, then it is better to do paired t test, because paired t test enforces homogeneity. You understand, the original experiment, the original sample thing is heterogeneous, okay, the original population is heterogeneous or samples are heterogeneous, you enforce homogeneity by conducting a paired t test, because you are, the way in which you do experiments itself is enforcing homogeneity. So that is the where you should think about doing paired t test, clear. So the drawbacks and advantages, drawbacks, it enforces a certain way to do experiments, paired t test, not always easier. As I said in biomedical, if I have to test the efficacy of my HRV ECG device, it is difficult to conduct experiment, because your ECG, the developed ECG and the gold standard ECG should be, the experiment should be conducted at the same time, ideal situation it should be conducted at the same time, right, otherwise you cannot compare. You understand the problem, and I cannot compare it after some time, because it will depend upon the sample, not only it will depend on the sample, it will also depend on the time. In biomedical it is even more complicated, because it will depend upon the time aspect itself. I cannot take 10 minutes later your ECG and compare it with the 10 minutes before, a lot of things would have changed, right. So the way in which you conduct experiments is restrictive, first thing, and you lose degrees of freedom, second disadvantage. The advantages, of course, it ensures homogeneity of samples, it ensures homogeneity basically, and the second case is it actually reduces the variance a bit, so that is a saving grace, or not saving grace, that is a consolation prize for doing t test, make sense. So these are the drawbacks and advantages of doing a paired t test versus a regular t test. So you should be clear when to pick what, okay.